Okay, now we're going to talk about ionization energy. So ionization energy is how much energy it takes to rip away an electron from an atom. The bigger the ionization energy, the harder it is to take away an electron. Okay? So if something has a really strong attraction to its electron, it's going to take a lot of energy to steal that electron away from it. Okay? So let's talk about it. So if we look at lithium versus sodium, on the periodic table, we know that electronegativity gets bigger as you go left to right and bottom to top. So lithium and sodium are on different rows of the periodic table, but they are in the same family. Okay? So when we're looking at up and down, okay, we're going to focus on energy levels. So let's look at the difference between lithium and sodium. Lithium has 2 energy levels, whereas sodium has 3 energy levels of electrons. Okay? So, ionization energy. Who is going to have the higher ionization energy? If you've memorized the rules, you should know that lithium is going to have the higher ionization energy. So this is going to have the big ionization energy, this is going to have the small ionization energy. Let's think about why. We're going to think about it in terms of Coulombic attraction. Kind of like magnets, okay? So, we're talking about the protons in here, this nucleus right here being attracted to that electron, protons in here being attracted to this electron. Okay? So, which nucleus is going to have a stronger pull on its outer electron? The answer is going to be lithium. Okay? The reason why is because those protons, those positively charged particles, are closer in proximity to the valence electrons, so they're going to have a stronger attraction. Remember that distance and attraction are inversely related. So the smaller the distance, the stronger the attraction. So you would say something like this. Going down the periodic table, the number of energy levels or shells or rings, okay, increases. This makes the distance between protons and electrons increase, which decreases attraction. Less attraction means it is easier to steal that electron. Right? And that should make sense intuitively. Okay? The closer the electron is to that proton, there's going to be a stronger force of attraction, which means it's going to take more energy to break that attraction. The farther away the electron is from the proton, there's less attraction, which means it doesn't take that much energy to steal the electron because it's far away. Okay? Now let's look at left to right on the periodic table. So now we're looking at lithium versus beryllium. Okay, they are on the same row, which means they have the same number of energy levels, so we can't compare energy levels. Instead, we're going to compare number of protons. So if you recall, lithium has 3 protons, while beryllium has 4 protons. Okay? So, we know that the stronger the charge, the stronger the attraction. Which means beryllium is going to have the higher ionization energy, while lithium has the lower ionization energy. So, from left to right, the number of protons increases. This increases attraction. Between the nucleus and electrons. The more attraction, the more energy it takes steal the electron. Alright.